All right, as promised in part 3, we're going to go through this one. So you started at 0, 0, and at 0, when I look at this, there's a slope of -1. So to do a slope of -1, I'm going to go down 1 over 1. Or I can go up 1, left 1. And I see that it is a slope of -1 all the way, always, for the rest of infinity and beyond. Over 1, up 1, over 1. So I get this nice little line here with a slope of -1. And notice I stopped at 1 because it says at x equals 1, my slope changes. It changes from -1 to +2. So at 1, here it had a slope of -1 on the left, and now over here I need it to have a slope of +2. So to do a slope of +2 and make this continuous, I'm going to start from this point and go up 2 over 1, up 2, 1, 2 over 1, and draw that function. So now my graph started at 0, 0. It has these slopes. So on the left-hand side of 1, my slope is -1. And on the right-hand side of 1, my slope is 2. And this is a continuous function for all x values. Fancy. All right, so one-sided derivatives, the right-hand derivative, these are the same definitions that we had before. The limit as x approaches a from the right. And again, we're going to do f of x minus f of a over x minus a. And the limit as x approaches a from the left of f of x minus f of a all over x minus a. And the one thing that we need to know is that if the limit from the right equals the limit from the left, then we can say the limit as x approaches a of f of x minus f of a exists. Okay, so if both of these two match, then this one works. It's very similar to what we did with limits earlier this year in chapter 2. So last but not least, we have example 5 at the top of the next page. And it says, show that the following function has left and right hand derivatives at x equals 0, but no derivative at x equals 0. So we want to show that the left and the right both work, but not necessarily the same thing. So if we do the slope of x squared and the slope of 2x, I'm going to cut some of this work out of here. This is just a straight line with a slope of 2. So that means that the slope of this one, so the limit as x approaches 0, and this is on the right-hand side, of f of x minus f of 0 over x minus 0, we know that that slope is going to be 2. Now we have to try x squared. So when we do the slope of x squared, we've done this many times before, but we're starting at 0, so our ordered pair is 0, 0, and then we're going to plug in 0 plus h. Well, 0 plus h squared is just h squared. So if we do the limit as h goes to 0 of h squared minus 0 over h, I did something wrong here. Nope, we didn't. We did it right. Then we end up with the limit as h goes to 0 of h squared over h, cancel, and cancel one of those. Now we plug in 0 and we get 0. So the right-hand limit was 2, the left-hand limit was 0, and because 2 does not equal 0, the derivative at x equals 0 does not exist. So the individual left and right did work, but the limit at 0 did not. All right, that is section 3.1. Make sure you've got all of these notes down, and we will be doing some activities in class with this information.